Hello everybody, welcome to my YouTube channel. I am Krishna Gopal. I completed my master from Indian Statistical Institute. In the last video, we gave an introduction about what is a linear regression, what are the assumptions in the linear regression. In this video, we're going to talk about how to measure the linear relationship between the response variable and the predictors. So we have the two terms, one is the covariance and one is the correlation. With the help of the covariance and the correlation, we can measure that how much y is depend on x. That means how much they are linearly related with each other. It is much more important in the context of a linear regression to know how your both the random variables are varying with each other. So let us suppose we have the n observation, we have the response and we have the predictor. We can calculate their sample mean, as y bar is summation of y divided by n and x bar is summation of xi divided by n. And the deviation, as we have the sample mean, so we can calculate the distance between the observed value and the difference between the observed value and their sample mean. So we can calculate for the x variable also and the y random variable also how much they deviate from their average line. That is the deviation. So when we see in the scatter plot, when we try to see the linear relationship, we have the curve like this. This is our predictors here, and this is our response. So if we draw the sample mean line in this plane, so sample mean line can divide this plane in the four part, that is the quadrant. So this is my y bar and this is my x bar. Suppose we have many point like this in every quadrant. So there are a lot of points we have in this. What we are going to discuss, as the x bar and y bar divide this plane in the four quadrant. This is the first quadrant, this is the second quadrant, this is the third, and this is the fourth. We're going to see how the x and y are linearly related with each other. So we have the four quadrants, so we can write like this here. The quadrant, the xi minus x bar, the deviation in the x random variable, and the yi minus y bar, the deviation in the y random variable, and their product. So xi minus x bar, yi minus y bar. So this is the first, this is the second, this is the third, we have the four quadrant. So xi minus x bar is positive in which quadrant? Xi minus x bar is positive in the first quadrant and in the fourth quadrant, because this is your x bar and the point here are the positive and the point that side is the negative. So the positive here and here. The y minus y bar is positive in which quadrant? So in the first quadrant and in the second quadrant. In the rest of the quadrant they are negative. So what is the, when we see their product, so if this is positive, this is positive, this is positive, else it is negative, this is positive, this is negative. So if x is increasing and y is increasing, then x and y both can increase. So we can see from their product what is the sign. So to determine this in more conceptually, we define the term known as the covariance. We define the covariance. We find the covariance between y and x, that is summation xi minus x bar, y minus y bar mathematically divided by n minus 1. This is the I is equal to 1 to n. So why here n minus 1? To reduce the biasness. to reduce the biasness, we use n minus 1 in place of n. So this is the mathematical formula for the covariance to determine how the two random variables are varying with each other. It actually indicates the direction in the linear relationship between the response variable and the predictors. So if covariance is positive, if covariance y and x is positive, that means what? If x is increasing, y is also increasing. If x is decreasing, y is also decreasing. If covariance is negative, then if x is increasing, y is the another random variable is decrease. Same in the vice versa. So with the help of the covariance, we can determine how the x vary with respect to the y. So, but it does not tell how much they are positively varying or how much they are negatively varying. It does not tell us about the strength of how they are both linearly vary with each other. So the major drawback in the covariance, when we calculate the covariance to determine the relationship is linear or not and how much it is linear, we only get to know about its direction. We don't know how much they are linearly related with each other. That means we don't know the strength. We only know the direction, how they are varying. They are the positively varying or they are the negatively varying. We only can comment in this. So this is the drawback in the covariance. Why it is a drawback? Because it is a scale dependent. That means what? If you have the two quantity, like you are measuring the 50 students height and the weight in your classroom. So if you measure the height in the centimeter and the weight in a kilogram in the first case, and in the second case you measure the height in the feet and the weight in the gram, this is the second case, and you try to find the covariance in both of the cases, the covariance is not equal to each other. Both the covariance is not equal to each other. That means what? When your unit changes, the covariance is changes. But it just tells us that okay, this is varying with this and this is varying with this. So the drawback in the covariance that it is a scale dependent. That measurement unit. So to get out of this problem, what we do, we standardize the features, because once we standardize the random variable, we come out from this problem that is if we measure in the centimeter or if we measure in the meter. By doing the standardization technique here, we can come out from this problem and then we can calculate the covariance. Then it will be equal, and that what we calculate after the standardization is known as the correlation. How? So how we do the standardization? We need to perform the standardization to both the random variables. So zi is equal to yi minus y bar divided by the standard deviation sy. Similarly for the xi minus x bar divided by sx. And then I calculate the covariance between the standardized y and standardized x, and that is termed as the correlation. So the correlation between y and x is summation I is equal to 1 to n xi minus x bar divided by sx yi minus y bar divided by sy. So this is the correlation. Also we can write, or correlation we can write as the, because this term is we see in the covariance also. So the covariance of y x divided by sx and sy. Now this correlation is not depend on the scale in which you are measuring. Either you measure in the centimeter or you measure in the meter. It does not depend on the scale. That is a scale that the correlation is the scale invariant. while the covariance is depend on the scale. So we use the correlation. Also it satisfy also the correlation. Why it is happen? Also the correlation between y and x is same as correlation between x and y, that it have the symmetric property. We easily can verify this result by seeing the formula. And the correlation between y and x is always lies between 1 and -1. So if correlation y and x tends to 1, implies we have the strong relationship between x and y. Strong relationship between x and y. If correlation tending to -1, we have weak relationship. But as we know, it lies between -1 and 1. What will happen when the correlation between y and x is 0? You're not going to say that the x and y are not are independent in this case. No, they can be dependent to each other, but not necessary they are linearly dependent to each other. If the correlation is 0, we can't comment that random variable x and y are the independent. It can be a case that they are not linearly dependent, because the correlation measure the linear relationship between an x and y. So this is the case that when we can say like if x and y are independent. Now already we know they are independent, then we can say 100% that the correlation is 0. But vice versa is not true. If correlation is 0, you have no proof to say they are independent. They can be dependent, but not linearly. In the non-linear context, they can be depend to each other. So this is what we study about the correlation. So this video is about the covariance and the correlation. We study in this video the two concepts: what is a covariance, what is its drawback, because it depends on the scale, how it and what is a correlation, how it resolve the problem from the covariance. So by ending this video, let me summarize what we study in the few minutes. We try to see how the linear relationship between the response and the predictor. We measure with the help of covariance first, covariance y comma x, but this have the problem, it is a scale dependent. And what it only tell the direction how x and y varies, not the strength, that how much they are varying. So as we know, it have a drawback, it is a scale dependent. To get out of this to remove this disadvantage in the covariance, we standardize the y and x, and we come up with correlation. That is a correlation is the covariance between the standardized y and standardized x. Correlation is lies between -1 and 1, and if it tending to 1, we have the strong correlation. If it tending to -1, we have the weak correlation. So this is the one of the most important concept in the context of the linear regression. If you have any problem to understand this video, let me know in the comment section. If you have any doubt about this video, about the concept correlation and the covariance, so I can help you. Also you can send me the question queries to the Gmail ID, which I will share in my channel. There also I try to help you, and but better if you put in the comment so other person also can see. And up to the next video, thank you and stay safe, and We'll see you soon in the next video. Thank you.